In section 6.4, we're looking at rational equations. So how do we solve rational equations? The first thing we want to do is multiply both sides of the equation by the LCD of all the rational expressions in the equation. Then we're going to simplify both sides. We'll determine whether the equation is linear, quadratic, or higher degree and solve accordingly. And then you can check the solution in the original equation. So let's take a look at example number 1. We have 2 over 3x plus 6 equals 1/6 minus 1 over 2x plus 4. So the first thing we need to do is find the LCD, and in order to do that, we need to factor the denominators. So this is going to turn into 2 over 3 times x plus 2 equals 1 over 6 minus 1 over 2 times x plus 2. And so from here we can figure out the LCD. So for the LCD, when we're talking about the number, we have a 3, a 6, and a 2. And so we want to go with the 6 because it can be broken down into 2 and 3. We also want to make sure that we include the x plus 2. Now looking at the LCD, if I were to set this equal to 0, what values of x would I not be allowed to have? Because we are talking about the denominator. So what value of x would give me 0? That would be x is equal to -2. And so we're just going to put a little thought bubble around this so we can come back to it. So x cannot be -2 because that would make my least common denominator equal to 0, and we cannot divide by 0. So what we want to do is we're going to multiply each piece by the LCD, or 6 times x plus 2. So we have 6 times x plus 2 times 2 over 3 times x plus 2 equals 6 times x plus 2 times 1/6 and then 6 times x plus 2 times 1 over 2 times x plus 2. And so now we're going to utilize cross multiplication to simplify. So the x plus 2 and the x plus 2 are going to cancel, and 3 goes into 6 2 times. Let's look at the next set. The 6 and the 6 are going to cancel, and then the x plus 2 and the x plus 2 cancels, and 2 goes into 6 3 times. So now we can see that the denominators have been completely crossed off, and we're just left with stuff in the numerator. So for this first term, what we had left over is 2 times 2. In the second term, we have x plus 2 times 1. And in the third term, we end up with a -3 times 1. And so we just want to simplify. 2 times 2 is going to give me 4. X plus 2 times 1 is just going to give me x plus 2. And then -3 times 1 is -3. So from here, we can combine like terms. We have a 2 and a -3. And so we end up with 4 equals x minus 1. Now we're trying to solve for x, so we can add 1 to both sides. And so it cancels on the right, and we end up with 5 is equal to x. And so what we want to make sure we do when we're solving rational equations is that we check the answer that we got with the condition we wrote down from the beginning. We said that x was not allowed to be -2. Now, had I gotten x equals -2 as a solution, I would have to throw it out and end up with no solution. But because our solution didn't break our condition of x could not be -2, x equals 5 is a perfectly fine solution. Let's go ahead and try another one. We have y squared minus 10 over y squared minus y minus 20 equals 1 plus 7 over y minus 5. So the first thing we want to do is we're going to have to factor the denominators. So we have y squared minus 10 all over. We have y minus 5 times y plus 4 equals 1 plus 7 over y minus 5. And so we need to find the LCD. Well, the LCD this time is y minus 5 times y plus 4. And so what two values of y am I not allowed to have? If I were to set the LCD equal to 0, what would we get? We would get y equals 5 and y equals -4. So this time we have two values of y that would cause the denominator to be 0. So if either one of these show up, I would have to throw out that solution. So let's go ahead and multiply each piece by the LCD. We have y minus 5 times y plus 4 times y squared minus 10 all over the LCD, y minus 5 times y plus 4. We have y minus 5 times y plus 4 times 1. And we have y minus 5 times y plus 4 times 7 over y minus 5. And so now that I've multiplied each piece by the LCD, we're going to use cross multiplication. So y minus 5 is going to cancel with y minus 5, and y plus 4 cancels with y plus 4. We can't cancel anything out with the second term, but we can in the third term, and the y minus 5s are going to cancel. So what we have left over is we have y squared minus 10 equals y minus 5 times y plus 4 times 1, and then we have 7 times y plus 4. And so we need to do a lot of simplification here. On the right-hand side, we're going to FOIL our two binomials. And we're also going to distribute the 7. So the left-hand side is going to stay the same. And so on the right, when I FOIL the binomials, I have y squared plus 4y minus 5y minus 20 plus 7y plus 28. And so now we need to combine like terms. I have a 4y, a -5y, and a 7y. And then I also have a -20 and a 28. So we end up with y squared minus 10 equals y squared. We have 4y minus 5y, which is negative y, plus 7y, and that gives me plus 6y. And we have negative 20 plus 28, which gives me plus 8. And so we want to get all the variables to one side. So I'm going to subtract y squared. And so it actually ends up canceling on the left and the right. And we end up with negative 10 equals 6y plus 8. And so solving for y, we're going to subtract 8 from both sides. And so on the right-hand side, these cancel. And we end up with negative 18 equals 6y. And to undo that multiplication, we're going to divide both sides by 6. And so what we end up getting is y is equal to negative 3. And remember, what you always need to do is you need to go back and check your answer. So let's go ahead and check. And since it doesn't violate any of those conditions, the solution that we found is valid. So y is equal to negative 3. Let's go ahead and try 2 more. We have z plus 1 over z squared minus 3z plus 2 plus 3 over z minus 1 equals 4 over z minus 2. So again, the first thing we need to do is we're going to factor the denominator so we can find the LCD. So this first one's going to factor as z minus 2 and z minus 1 plus 3 over z minus 1 equals 4 over z minus 2. And so we need to find the LCD. The LCD this time is going to be z minus 2 times z minus 1. And so what values of z can we not have? We cannot have 1 or 2. So what we're going to do now is we're going to multiply each piece in this equation by the LCD. So we have z minus 2 times z minus 1 times z plus 1 all over the LCD. We have z minus 2 times z minus 1 times 3 over z minus 1 equals z minus 2 times z minus 1 times 4 over z minus 2. So let's go ahead and cross some stuff out. Z minus 2 is going to cancel, and so is z minus 1. In the second term, we have z minus 1 canceling, and in the third term, we have z minus 2 canceling. And so what I have left over is z plus 1 plus 3 times z minus 2 equals 4 times z minus 1. And so I need to simplify this. So I am going to distribute the 3 and distribute the 4. So we get z plus 1 plus 3z minus 6 equals 4z minus 4. And so on the left-hand side, we can combine like terms. I have a z and a 3z and a 1 and a negative 6. And so I end up with 4z minus 5 equals 4z minus 4. So let's go ahead and get the z's all to one side. I'm going to subtract 4z from both sides. And so what ends up happening is that it cancels on the right and on the left. And so what I end up with is negative 5 equals negative 4. Now this is not a true statement. And so because this is not a true statement and all the variables canceled, the answer is going to be no solution. And let's go ahead and try one more. Same process as before. We want to make sure that we factor the denominators completely. And so what we're going to end up with is 4y over y plus 3 minus 12 over y minus 3 equals 4y squared plus 36 all over, and this is going to turn into y plus 3, y minus 3. So my LCD in this case is y plus 3 and y minus 3. So what values of y can I not have? I can't have negative 3 or 3. And so we just keep that for the end. But now what we want to do is we're going to multiply each term by the LCD. So y plus 3 times y minus 3 times 4y over y plus 3 minus y plus 3 times y minus 3 times 12 over y minus 3 equals y plus 3 times y minus 3 times 4y squared plus 36 all over y plus 3 times y minus 3. And so now we want to cancel. Y plus 3 cancels with y plus 3. Y minus 3 cancels with y minus 3. And then y plus 3 and y minus 3 are going to cancel. So what I have left over is 4y times y minus 3 minus 12 times y plus 3 equals 4y squared plus 36. And so we need to distribute the 4y and the negative 12. So we end up getting 4y squared minus 12y minus 12y minus 36 equals 4y squared plus 36. So let's go ahead and combine like terms. On the left, we can combine the negative 12y's, and so we end up with 4y squared minus 24y minus 36 equals 4y squared plus 36. I'm going to get my y squareds together, so I'm going to subtract 4y squared from both sides. So what ends up happening is that it cancels on the left and the right, and I am left with negative 24y minus 36 equals 36. And since we're solving for y, we're going to add 36 to both sides. So on the left it cancels, and we end up with negative 24y equals 72. And the last step is to divide both sides by negative 24. And we get that y is equal to negative 3. And so remember, you always want to check with what you said we weren't allowed to have. But one of the restrictions was that y was not allowed to be negative 3. And that's exactly what we got. So because we can't use this as a solution and we have no other solutions to choose from, this one is going to be no solution as well.